Hey everyone, for lesson 2 of unit 4, we're going to be expanding on the idea of simplifying a radical by learning how to add and subtract them. Essentially it comes down to the idea of combining like terms. And so I'm going to give you a few examples of combining like terms. Remember, a like term is anything that shares the same variable and the same exponent, okay? So we can combine those and say if I have 3 apples and 2 apples and I add them together, I have 5 apples. I don't have 5 apples squared, I just have 5 apples. If I had 3 apples squared and 2 apples squared, then I have 5 apples squared. I know that sounds weird, but we don't want to mix things up. Like if I said I have 3 apples and 2 apple squareds, those are not the same thing, okay? Even though that they're related because there's apples involved, one's apple squared and one's apples, so they don't go together. So if I look at example A here, I have x plus 7x. And really, the idea of combining like terms comes down to finding the GCF and then combining what's left over. So in this case, we can see that the GCF in both of these terms is x. And so if I factor out the x, now normally we write the x out front. Let me go ahead and do that because that's what you're used to. Normally we take the x out front. Well, what's left over here, the coefficient is a 1 and left over here is a 7. And so we can add those together and say x times 8, or that just simplifies to 8x. The more traditional way of writing it when you're combining like terms is to say, okay, I got x plus 7x. They both have x involved, so I'm going to put that at the end and then put 1 plus 7 inside in the front. And so I'm left with 8x. Now you knew that x plus 7x is 8x. It's combining like terms. You did that all last year, and we've done that before. But I wanted you to see it this way so that you know what to do with a little bit more complex things. All right, so option B, or example B, we've got 8x squared y, and then minus 3x squared y. So what do they have in common? Well, I can see that they both have, oops, using the same color here. Same color. They both have the x squared and they both have the y. So the GCF in this case is going to be x squared y. And then left over here is going to be 8 and left over here is negative 3. So we can combine those to say 5 x squared y. Another way of looking at this is saying, let me rewrite the problem here. I have 8 of this thing minus 3 of the same thing. So how many do I have? Well, I have 5 of that thing. Notice nothing changed with the variables and the exponents. It's just how many do I have? And that's what it means to combine like terms. For C, we have 6, and this is the cube root of x. We'll talk about cube roots later on. But the point is just to see like terms. So we can see that this has a cube root of x, and so does this have a cube root of x. So I can identify those as the GCF and say the cube root of x is taken out, and what's left over is the 6 and the 2. So what do I have? I have 8 cube root of x, and that is my answer there. Okay, so that was just a kind of a quick run through of combining like terms, something that you should kind of already know. You should have a really good understanding of it, in fact. But when we talk about radicals, they tend to be a little bit tricky. So we want to see that for what it is. All right. So now let's go ahead and look at an example of subtracting and adding radicals. Yesterday, or the last lesson, last video, we talked about simplifying radicals. Well, what do you do once you have simplified radicals? What's the next step? Well, there could be a multitude of things. It could be adding them, subtracting them, multiplying and dividing them, and doing more work with them, but this is one of them. We look at 3 rad 7 minus 5 rad 7, and we recognize that they are like terms. What do they have in common? Well, they have a radical 7 involved. That is the GCF, so we can take out a radical 7, and what's left over is the 3 minus 5. So 3 minus 5 is negative 2, because those are now just numbers, and then the rad 7 is after it. And so that is our answer. Now, if we can simplify the rad 7, we should, but 7 is a prime number, so there's no simplifying that we need to do there. For E, we have, I better make some room here. It's going to take a little bit more room for this particular problem. We have the square root of 75 plus the square root of 48 plus the square root of 45. Now here, we don't have any like terms. None of these are alike. So on the very first step, you might say, well, we can't combine them, we can't do anything with it, we're done. We can't do anything. But remember, we want to try and simplify the radicals if we can. So this goes back to the last lesson. How do I simplify rad 75? Well, the first thing I need to do is I need to factor it. So this is 25 times 3, that's prime. And then 25 factors of 5 times 5. So rad 75 factors to 3 times 5 times 5. 48, I'm just going to kind of do in my head, just not to waste the time. 2 times 2 times 2 times 2 times 3. 2, 4, 8, 16, 48. Okay, so that's that. And then rad 45, I'll do the cake method here. Rad 45 factors to 3 times 15, 3 times 5, 5 times 1. So we're left with 3 times 3 times 5. All right, now we can do our prison break, or simplifying the radicals. Remember, we look for pairs. So in this case, we have a pair of 5s. And so this guy will simplify to 5 radical 3. And then here we have a pair of 2s and another pair of 2s. So that will simplify that one of the 2s goes out, another one of the 2s goes out there, and the radical 3 is left over. And in the last case, we have a pair of 3s. And so that's going to simplify to 3 radical 5. So before we can do anything else, we need to simplify this 2 times 2. And you could have done that all in one step. 1, 2 times 1, 2 is 4. So you could have just written that down. So you get 5 rad 3 plus 4 rad 3 plus 3 radical 5. Now we can combine like terms. Notice they're not all alike. This has a radical 3, this has a radical 3, but this has a radical 5. So that's not alike. Now somebody might say, well, that's got a 3, and a 3 in it. That's true, but these are square roots of 3, not 3. And this is 5, not the square root of 5. So this is not a like term with these guys, but these ones are. The square root of 3 and the square root of 3 go together. So I can carry those down, square root of 3, factor that out, and what's left over here is 5 plus 4. And in this guy, I couldn't take anything out, so I'm just gonna carry that down. I'm just gonna leave it alone. From here, 5 plus 4 is 9, and rad 3, plus 3 rad 5. And again, I can't combine those because the radicals don't match. There's nothing alike about them. So I would just say that is my final simplified answer. So the idea is to simplify each radical as much as you can, and then identify which radicals are alike and combine those terms. So here we had square root of 3, square root of 3, so we can combine them. Okay? So that is the essential process. Okay? So 9 rad 3 and 3 rad 5. Let's go ahead and go on to some practice problems. I'd like you to try these. So pause the video, try them on your own, and then come back and watch the video to make sure you're good with them. All right, for number 1, we have 5 rad 6, 5 radical 6, plus 2 radical 5, minus rad 6, plus 7 radical 5. Now you'll notice right away that some of these are alike. I've got a rad 5 and a rad 5. And I have a rad 6 and a rad 6. So these guys can go together. So I'm going to put them next to each other first. I'm going to write down 5 radical 6 minus radical 6. And I'll put these next to each other. So it's plus 2 rad 5 plus 7 rad 5. Just so that I can work with them a little bit easier. Since these guys have a common rad 6, I'm going to go ahead and carry that down. And well, what's left over? When I factor out the rad 6, I get a 5 left over and a negative 1. And so that becomes 4 radical 6. For this one, let me go ahead and get a different color here. I've got radical 5s that go together. And so I'm left with radical 5 on the outside with a 2 plus 7 on the inside. Be adding those. So that'd be 9 radical 5. And those are not like terms because the radicals are not the same. So that is my final answer. Okay, so that's number 1 there. Number 2, let's see if we have room for number 2. Number 2, we have 2 plus 2 rad 2 plus radical 8 plus 3 rad 2. Now, right off the bat, we can see that a rad 2 and a rad 2 go together. So we could rewrite that. We could say 2 plus 2 rad 2 plus 3 rad 2 plus rad 8 if we wanted to. And then we can combine these and put the rad 2's together. These are like terms. Now, you could go through and rewrite it like this by factoring out and everything else, but that's just a good way of seeing it. But a quicker way is to say I've got 2 rad 2's and 3 rad 2's. So when I add those up, 2 plus 3 is 5 radical 2 without showing this step necessarily. Now from here you might say, oh, I'm done. But keep in mind, you should simplify radicals first. That should have been our first step. Now 2 is a prime number, so I can't simplify that one anymore. But the radical 8 can be simplified. So I could do it now and then keep going, but I should try and do that from the very beginning. That should be the process. Always simplify the radical first and then combine like terms. So the radical 8 factor tree, that's 4 times 2, 2's prime. 4 is 2 times 2, those are both prime. So here I have radical 2 times 2 times 2. Okay, and I'm just going to do this off to the side and I'll plug in what I get over there. So I've got a pair of 2's. So those, remember, one of those goes out, the other one disappears, and then that 2 is left inside. And so now the 2 rad 2 replaces that radical 8 there. So I'll rewrite this as 2 plus 2 rad 2 here, plus, instead of rad 8, I'm going to put 2 rad 2 because I simplified it, and then plus 3 rad 2. Now I can see that I've got a rad 2, and a rad 2. Those are all alike. This guy is not alike, so I'm just going to write that at the beginning. So we got 2 plus, let's see, I got 2 rad 2's plus 2 more rad 2's plus 3 rad 2's. So I've got 7 of those altogether. 7 rad 2's. And that is my final answer. Just in case you didn't see where I got the 7 from, I took a rad 2 out of all of those. And what was left over was this 2, and that 3. So 2 plus 2 plus 3 is 7. Okay, so that is number 2. And then number 3 is it got some bigger numbers here, so we're gonna have to erase the board so we have more space to work with. Number 3 has 3 rad 5, plus rad 20, minus 4 rad 125, big number, and then plus 9 rad 5. Well, I recognize that the rad 5 and the rad 5 can go together, that's fine. And in fact, 5 is prime, so I don't need to simplify those. But before I combine those like terms, I'm going to go ahead and simplify those radicals. Rad 20, the prime factorization of rad 20, I'll do the work down here, is going to be 2 times 2 times 5. And if you need to do a factor tree or the cake method to see that, that's fine, but it is 2 times 2 times 5. 2 times 2 is 4, times 5 is 20. So what I get when I simplify this radical is 2 radical 5. For the other one, I've got radical 125. Well, that factors to 5 times 5 times 5. Again, you can do the factoring tree if you need to see that, or the cake method. Circle a pair of 5's. What's left inside is 5, so we got radical 5 inside, and then one of those 5's goes out. And so now I can plug those into what I have up here. I've got 3 radical 5, nothing changed there. The rad 20 turned into 2 rad 5. Now this one has a minus 4 out front, but notice it says minus 4 times radical 125. And radical 125 is 5 rad 5. So I would say negative 4 times 5 rad 5, and then plus 9 rad 5. Now, we can see that every term has a rad 5 in it, so that's good. That should simplify nicely. But I got to simplify this negative 4 times 5 first. So we got 3 rad 5 plus 2 rad 5 minus 20 rad 5, right? 4 times 5 is 20, plus 9 rad 5. Now we can see that they're all radical 5, so I can take that out, and then I can see I got 3 plus 2 minus 20 plus 9. Well, 3 plus 2 is 5, minus 20 is negative 15, plus 9 is negative 6, I believe. So it'd be negative 6 radical 5 as our final answer for number 3. Let's see, let me double check that. Negative 11, negative 9, negative 6 rad 5, that's correct. All right. Okay, so that wraps those problems up. Make sure I'm right on this one, negative 6 rad 5, so we're good there. And we have one more problem to go over here, and there's a little bit of an application to geometry. So go ahead and pause the video and see what you come up with, and then come back and compare. All right, for number 4, it's asking for the perimeter of that triangle. Now let me draw the triangle here. We've got rad 40, rad 90, and 4 rad 10. We're looking for the perimeter of this guy. Remember, perimeter is the distance around an object. So if I start on one corner and I just walk around, how many steps do I have to take, or how far around is it? Well, it's 4 rad 10 from this point to this point, rad 40 from this point to this point, rad 90 from this point to this point. So the perimeter is just going to be all of those added up. So the perimeter will be 4 rad 10 plus rad 40 plus rad 90. Now we would simplify this. So remember, the first step is to simplify the radicals. And I'm not going to go through the big long process here. I would expect you to show the work. Rad 10 doesn't simplify, so we rewrite that as 4 rad 10. Rad 40 simplifies to 2 rad 10. Again, prison break, cake method, factor tree. Rad 90 factors to 3 rad 10. Okay, again, I'm not showing the work for that, but I would expect you to do that. We've been doing that for a couple days now. And then we can combine like terms. I've got rad 10s everywhere. So I've got 4 of them here, plus 2 of them there, plus 3 of them there, which would make 9 radical 10 as a final answer. So the perimeter is 9 rad 10. And that's the form that I wanted it in. Let me make sure my answer is correct. And in fact, it is. All right, so this lesson was dealing with adding and subtracting radical expressions, and it just builds off the idea of simplifying radicals first. So again, simplify the radicals, and then combine like terms by identifying which radicals match. These all have the same radical, so I can combine them all. If you have any questions, comment below, or ask me for help when we meet in our next Zoom meeting, and I will talk to you later.